Why doesn't SpaceX send humans to Mars first? Why send robots to build the city before people ever arrive? Stay until the end, because if they get even one step wrong, everything could freeze on day one. If you build a base on the moon, you still have a way home that's about a day away. Run out of supplies, something breaks, you can resupply constantly. But Mars isn't like that. A trip today can take around 8 months. Even if future nuclear propulsion cuts it to a few dozen days, it's still too far away to rely on regular shipping. That's why a Martian city must meet a brutal standard. It has to produce its own water, oxygen, energy, fuel, building materials, and food. If Earth's ships stop coming for any reason, war, crisis, or simply economics, Mars still has to keep going. Mars is not a promised land where humans can show up and figure it out. Step outside without a pressure suit and you can freeze, suffocate, and have the moisture in your body boil away on top of radiation from the paper-thin atmosphere. So SpaceX won't open with romantic settlers. They'll open with robots. Humanoid robots like Tesla Optimus, autonomous, AI-driven, are imagined as the first construction crew, installing equipment, digging for ice, running cables, assembling modules, making repairs, and operating the station. The optimistic scenario is that SpaceX could send the first starships carrying robots to Mars during launch windows, with one simple goal: successfully land at least one ship. SpaceX is famous for test, explode, learn, repeat. Once the process is locked in, they can iterate fast and scale. To survive, you need water, and on Mars, water usually means ice. So site selection revolves around places with ice, relatively flat terrain, and locations closer to the equator to maximize solar power. Arcadia Planitia, a broad plain near the Olympus Mons region, is often cited as a strong candidate because it may hold large reserves of water ice beneath the surface. When the robots arrive, the top priority is building a water plant. Not just for drinking. Water is the key to life and industry. Melt and purify ice into usable water. Electrolyze water to make oxygen to breathe. Produce hydrogen as an energy input and a core ingredient for fuel. But if you want to return or expand, you need a fuel plant. Bringing fuel from Earth is simply too heavy. SpaceX chose methane for Starship because it's easier to handle than ultra-pure hydrogen. On Mars, you get hydrogen from water and carbon from the thin CO2 atmosphere. A system that captures CO2 and synthesizes methane turns air into rocket fuel. Bonus, it also produces oxygen. Since ice is often underground, you have to dig. So, along with humanoid robots, there would be compact excavators, drills, and mining hardware. Think tunneling tech as an inspiration. And the dirt and rock you pull up isn't waste. It can be crushed, heated, and processed into hardened surfaces for roads, landing pads, and foundations. As that infrastructure comes online, every subsequent Starship landing becomes safer, faster, and more capable. When humans finally arrive, energy demand explodes. Robots can get by on charging and a modest solar array. But life support systems must run 24/7. Oxygen, water, heat, pressure, and air filtration. A Martian day is close to Earth's, so roughly every 12 hours it gets dark. Solar has to be paired with massive battery storage. The idea of shipping industrial-scale battery packs, something like Megapack, shows how SpaceX could bring an entire mini power grid to Mars, at least enough for a small settlement to survive the night and endure dust storms. For housing, Starship can be a temporary shelter, but it's not a long-term home. Tall, narrow, and impractical. So you have to build habitats. And this is where use local resources becomes the deciding principle. A lot of people imagine giant glass domes, but glass and that kind of structure are extremely heavy and would require hundreds of flights. A more practical concept is an ice dome. Ice insulates and is an excellent radiation shield. You bring an inflatable core module from Earth, robots set up a mold, then pump water and freeze it into a dome shell. Ice domes still let light through, helpful for circadian rhythm and morale. And if you need a tough, versatile shell for workshops, labs, and factories, you can use the rock you excavate. But rock needs a binder. Here's the part that sounds shocking. Urea processed from urine can be mixed with soil to create a material like astrocrete/biocrete, sometimes described as very strong. In other words, waste isn't trash, it's a construction resource. Water and oxygen can be handled by machines. Fuel can be synthesized. But food is the long game. Martian soil may contain perchlorate chemicals that hinder growth and are toxic. There are two hard options: ship soil from Earth, impossible at the city scale, or build industrial systems to detoxify Martian soil and add nutrients. And once again, bio-waste matters. Organic waste can become fertilizer, enabling a closed biological loop for greenhouses, hydroponics, and sealed growing systems. A city only truly stands when it can feed itself. From closed-loop greenhouses and nutrient stores to water recycling processes and planting schedules built around dust storm seasons. A small outpost with a few dozen astronauts can survive on stored supplies and periodic resupply. But a city means a population large enough to repair itself, manufacture essentials, and train the next generation. In one commonly cited scenario, before Earth suffers a disruption that cuts off support, Mars could need around 1 million people living and working there to provide enough labor, skills, and internal supply chains. That's why SpaceX talks about fleets of starships arriving in waves, using the roughly 26-month launch windows when Earth and Mars are closest to steadily increased population and industrial capacity. And radiation protection may mean the first structures won't sit exposed on the surface the way we imagine. Robots can dig trenches, bury habitats under regolith, or create tunnels, turning Martian soil into a natural shield. Once you have roads, landing pads, cold storage, repair shops, and logistics, you start to see what matters most: the ability to maintain a stable rhythm of life, even when the outside world is dust storms and temperatures tens of degrees below zero. So, how will SpaceX build a city on Mars? Through a very industrial chain of steps. Robots go first, build water and fuel plants, mine resources to create infrastructure, bring humans to expand power and housing, and then turn local resources from ice, CO2, and rock into even waste into the foundation of a self-sustaining society. A city where every drop of water, every watt of electricity, and every square meter of greenhouse space is a victory over an 8-month distance and a hostile environment. If you enjoyed this video, hit like, leave a comment below, and subscribe so you don't miss the next one.